Now let's see in the partitioning how this relocation is performed. So one thing is this, relocation is performed by the loader that you have already seen, right? So whenever a process is going to be loaded into the main memory, the entire relocation is done by the loader, fine. But the problem with this software approach is, it is a software approach, right? The problem with this software approach is, if your process is going to be pulled out of that memory and again it has to be reloaded at some other place, see what happens is this. I'll just take an example and I'll just show you. Assume that this is the user space. User space means wherever your process are going to be loaded. This is the operating system and this is the user space. And let us say the user space has started at address 100k. This is the 100k. And now you have loaded a process P1 in this. Now when you are loading the process P1, inside this process there are various instructions which are relocatable addresses, right? And all those relocatable addresses would have been converted into absolute addresses by the loader. But then which means, see this, what will loader do is, if you have some instruction as go to 10, then what will loader do is, it will make this go to 10 to go to 10 plus 100k. This is what your loader will do, right? And now later if this process has to be swapped out, so sometimes what happens is, a process will be waiting for IO and then it will be present in the main memory, but still it will be occupying some space and it will not be executing anything on the CPU. Then it is obviously the better choice is send it out and then get some other process in its place, so that your CPU will be busy, right? So now process P1 is outside and let us say process P2 has been loaded, right? And then assume that process P1 is again next time loaded at some other position which is 200k, at 200k, right? Then what should happen now? The same instruction which is having go to 10 plus 100k, it has to be now changed to 200k, 10 plus 200k. But then the problem is, it has already been changed to some address. Now there is some number and loader will now get confused. Loader will try to add 200 plus 100k plus 10 because it doesn't remember what the original value is, right? Therefore a loader will be useful only if you can know that the process is going to remain at the place where you loaded it. But if the process has to go out and again get in, if you use loader 2 times, loader will get confused, it cannot work. Obviously operating system has to find some other solution, and the general solution which operating system has found out is, instead of using this load time binding, it is going to use runtime binding. Runtime binding means it is never going to do anything like this. It is never going to convert the relocatable addresses to absolute addresses. It is going to leave them as it is, and then whenever a address is generated by the CPU, then that particular address will be mapped to the physical memory, right? So then the concept of logical address and physical address will come into picture. See this? Anytime when the CPU is generating or running a process, then it will generate some addresses, right? The addresses generated by CPU when it is running a process are called as logical addresses. So in this case, you can even think of this logical addresses relocatable addresses, right, which are relative to 0, which means every process, we imagine that, or we assume that every process is going to start at address 0, and therefore that relocatable addresses will be used, and they are also called as logical addresses, right? And now somehow these logical addresses have to be converted to, this entire part is called memory manager. Somehow these logical addresses have to be converted to physical addresses and then given to the main memory, because the process is going to be present in the main memory in some part, and that should be referred by the physical address, right? So according to CPU, it will generate some address. It doesn't know that a process is loaded at some other point in the memory, and now memory manager knows that the process is loaded at some point, some place. Therefore memory management should take the can be fetched from the physical memory. Got it? So what I mean to say is simple. Involving the loader in order to convert relative relocatable addresses into absolute addresses is not a good idea when the processes go out and come in. and it is very often the case that the process will go out and come in into the main memory. That is called as swapping out and swapping in, right? Why do we do that? Because many processes will be useless, or whenever they are doing IO, we don't want to waste the memory allocating to them. I could run a other process, right? Then what we do is we do operate by, as operating system, we want to perform this relocation, which means this mapping, converting this logical address into physical address. See, from now on, this relocatable address, I call it as logical address, or any address that is generated by CPU is generally called as logical address, and the CPU thinks that a instruction is present starting from, the program is present starting from instruction 0, but then the memory manager would have loaded it somewhere else. Therefore, it is the responsibility of memory manager to convert the logical address into physical address. Got it? Okay, so one thing is, now we have to perform this relocation. So at various levels, various kinds of techniques are used, and one basic technique used in this case of partitioning. I am talking about partitioning. What is partitioning? We are dividing the memory into partitions and we are loading the process into a partition, or it is also called as contiguous memory allocation, which means I am going to allocate some memory for a process contiguously. A process is going to be present completely and contiguously in the memory. So in this contiguous memory allocation, this particular memory management is going to be useful or efficient, right? So what we do is, watch it. So now assume that what I am trying to say is, let us say a process is loaded at the starting address 100K, right? Then what I do is, I'll maintain a register which is called as relocatable register. This one, relocatable register. In the relocatable register, I'll load 100K. It is saying that this particular process is going to start at 100K, and let us say the size of the process is 100 bytes, which is not real, but then let's assume that it will be simple, right? And now this one is going to be loaded in the limit register. Therefore, limit register is going to contain 100, right? So according to CPU, the program is starting from 0 and running till 100. That's it. Running till 99. 100 words means 100 bytes means 99. So according to CPU, the program is loaded at 0 and running at 99. Therefore, all the addresses in this process should refer only the numbers between 0 to 99. It should not refer anything beyond that, right? So if it refers anything beyond that, then it means that it's trying to access some other memory which should not be allowed, right? Therefore, whenever a CPU generates the logical address, which is nothing but the relocatable address in this case, then it will be compared against the limit register. So what does the limit register say? 100. Therefore, whatever address you generate, it should be less than 100. In case if it is less than 100, then definitely it means that we are trying to access the memory which is present in this process itself, right? And now it has to be converted to physical address, right? So how can you convert it to physical address? So we are going to take this 100K, right, and then add that particular number. Let us say the address generated is 10, right? If 10 means, from here 10 is somewhere here, isn't it? So now, even though the address generated is 10, by the CPU, the 10th byte in the process is actually 100K plus 10 in the main memory, right? So therefore, whatever address is generated, to that this relocation register is going to add the base, which means finally, even though 10 is generated here, the final address that will be given to the main memory will be 100K plus 10, right? And therefore, when this address is kept in the memory address register, we shall look at it later. What is memory address register is, if you whatever address you put on that register, that will be given to the main memory, and main memory is going to take the byte which is present, or the word which is present in that location, and is going to return it to the CPU. Got it? So even though you are referring to 10, finally the word which is present here will be coming out. Now what are the advantages by using these two registers is, one thing is protection, which means your process can never refer to anything which is outside this particular partition, isn't it? Because this comparison is going to help us. In case if it tries to refer anything outside it, it is going to stop it. It is going to raise a trap. Trap means that is a different condition, and again that will be handled, right? And second thing is relocation. So relocation is the key thing, right? So here in this organization, whenever we are going to pull out the process and then put it in a different location, if you do convert this relocatable addresses to absolute addresses using a loader, when you put it in a different location, it will create a lot of problem, right? Therefore, whenever every process will be having these two values associated. Whenever you change the process, whenever you move around, then this relocatable register is going to change, even though the limit register is going to be constant. So if you move this process around, right, depending on where you try to load it next time, this relocation will be done, changed. Let us say next time you pull this out and again you reload it at 200k, right? Then what happens is this one will be changed to 200k. Then nothing need to be changed, only this part will be changed and everything will work fine. That is the beauty of this concept, right? So relocation is very easy. You can move out and move in. Now the problem is these two registers should not be given to any process. The process should not be asked to set these registers. If you ask a process to set it, then what happens is there could be some malicious actions possible. It will try to increase the limit, which means it will try to access the memory which is outside its existence, and then it will even try to change these relocation so that it can access any code, right? That is why these two registers are set by operating system, right? So these two registers are under the control of operating system, and they will be set whenever a process is running. So let us say whenever a process is running, CPU is running process P1, then these two registers will contain the corresponding values of this process P1. In case if you switch the context, whenever you switch the context from P1 to P2, let us say it is P1 and it is P2, then these corresponding registers will also be changed according to the the locations in which P2 is present. Therefore, these are actually privileged registers, or in order to access these registers, we need special privileges from operating system. That is how operating system can provide both the protection as well as relocation. So there is a small disadvantage here compared to software. See, if you don't use this method, then obviously the software method should be there. What is software method? For every instruction, for every logical address generated, operating system should be called, and operating system should be asked to convert it to physical, this physical address. But the problem with that is, see, you are running a process. Now the process has generated an address. Now the operating system has to check whether that address is valid or not. In case if it is valid, it has to convert it to the other address, right? So it is going to be very, very difficult. In the sense, for every instruction you should call the operating system code. There has to be context switching between user process and the operating system. That is going to be very, very slow. So that is why we don't use a software method, we use the hardware method. And hardware method, you need not involve any operating system. You can directly use these two registers. Yes, even though it is faster, still it is slower in general. It is faster compared to any other method available, but still it is slower if you talk normally. The reason is, for every logical address generated, we are supposed to do one comparison and one addition. That is obviously a disadvantage. But still, we don't have any other option. People have used it when they were using this partitioning method. Got it? So this is how this protection and relocation are implemented in contiguous allocation. See, whatever I told you here, it is all applicable to contiguous allocation, right? Later, when the memory is not allocated in a contiguous manner, there are other ways, right? So this memory manager, this is a memory manager, right? So this entire unit is called memory manager, is useful when we are using contiguous allocation. Got it?